Hello students, today we are going to see about the timer programming. Timer programming, we have in timer of 8051 we have three registers, timer register 0 and 1 and T mod register and T control register. So timer register 01 is a 16-bit register. You can access this timer register 0 and 1 by even 8-bit register as an 8-bit register, namely TL0 and TH0. Similarly, TH1 and TL1. Okay, as a individual 8-bit register, you can access these register. You can, if you want to move the data into these register, you can use the normal move instructions for data transfer instructions for moving data into the timer register. And coming to the timer mode register and timer control register, these are 8-bit registers, and we can see how to use this T mod and T control register while doing programming in by using timer register. So coming to the timer register, okay, coming to the timer register, T mod register is nothing but you are going to uh, um, program the modes of the timer register. It's an 8-bit register. It's an 8-bit register. You have 8 bits here. So one is your the lower 4 bits. The lower 4 bits is used for timer 0. It is again gate C bar T M I or M1 or M0. Okay, M0. So for lower 4 bits are used for timer 0 and upper 4 bits are used for timer 1. This is used for setting up various operational modes of timer. Okay, various operational modes of the timer register. So coming to your timer 1 or timer 0, you have for timer 0 and timer 1 you have these 4 bits common, namely gate C bar T, M1 and M0, M1 and M0. So gate, so this gate bit is there for the timer 1 also. It is also there for the timer 0. It is also there for the timer 0. So gate 0, it is nothing but if I am giving 0, if the gate bit, if I am giving 0, this gate bit, each and every bit can take two values. If I am giving 0, that meaning is that you are going to use software related control for the timer. Software related control for the timer, meaning for example, if you need to start the timer or the counter register, for example, if you need to count the number of persons entering into the room, so you need to instruct the 8051 microcontroller that start the counting. Okay, these instructions can be given by using software related instructions, namely set B and clear B, because the timer start bit, that is this timer start bit, it is TR bit, it is available in the TCON register. It is available in the TCON register. This timer start bit is available in the TCON register. So this using this timer start bit, we will be doing software related control, meaning set start the counting means set B TR0 if I am using timer register 0. For example, if I am using timer register 0 for counting the number of person entering into the room, what I will be doing is I will be using this timer register, timer control register, the TR bit of the timer control register. If the TR bit of the timer control register is 1, meaning I am instructing the 8051 microcontroller to start the counting. If to stop the counting, I will clear the TR bit. Okay, again in the TCON register, meaning timer control register, I'll be having two TR bits, one for timer register 0 and another for timer register 1. So if it is not by software related, if you are not going to set the timer or the counter by using software related instruction or software instructions, if by using external hardware, if you are going to start the timer and stop the timer, that is that can be done only by setting this gate to be 1. Okay, so hardware way to start and stop the timer by using any external source. What are these external sources? Okay, so these external sources, when gate is equal to 1, these external sources are nothing but in the interrupt. In the you have it's a 40 pin IC, you know already. 8051 is a 40 pin IC. You have two pins. One is INT X, which is nothing but it may be interrupt 0 and interrupt 1. These are said to be external interrupts. External interrupts, if you have external interrupts that is happening in the INT X pin, maybe 0 and 1, or TRX, okay, TRX. TRX pin, you have serial communication pin. So if through this pin, via this pin, if you have 1, meaning if these pins are 1, enabled as 1 by any other external source that is being connected to 8051, provided when the gate is 0, okay, when the gate is 0, your the timer register or the counter register will start its own timer related operation or counting related operation. Okay, this is purely by the external source. And the next one is C bar T, okay, C bar T, which is nothing but 0 and 1, which is nothing but 0 and 1. So C is your if a C bar T pin, okay, if C bar T pin is this one, the next one, the C bar T is the next one. And the C bar T, if one can this can be used as a counter as well as a timer, counter is nothing but counting the number of persons entering in a room, and timer related operation, within this particular time you need to finish your work, that is timer related operation. So you can use these two registers, timer 0 and the timer 1 register, can be used as a timer as well as a counter. If it is used as a counter, you will be making this bit as 1. If it is used as a timer, you will be making this bit as 0. So for this case, the source for the timer will be the internal clock. You have an internal clock, a crystal oscillator clock. Using this clock, you will be using those registers as a timer register. And counter related operation, the input will be the TX pin or the transmission pin, whichever we are having in the 40 pin IC. And coming to the other two bits, M1 and M0, these are mode bits. These are for setting up the timer modes. For setting up the timer modes, you have four different modes. Namely 0 0 0 1 1 0 1 1, because these are two bits. You have 4 possible combinations, namely 0 1 2 3, that is time mode 0, mode 1, mode 2, mode 3. If it is mode 0, it is a 13-bit timer mode. If it is mode 1, it's an 8-bit timer or counter, or 16-bit timer or counter. And whereas this is okay, and these two operations, mode 1 I'll discuss with you. And similarly, it is mode 2 is nothing but an 8-bit auto reload feature, and the third one is your split timer mode. Okay, split timer mode. And one more register what we have here is your timer control register. It is also an 8-bit register. This is also an 8-bit register. So now you have 8 bits here, provided this whichever is highlighted in yellow, that is for timer 0, register, and whichever is not highlighted, that is for timer 1. Of which, of these 4 bits, we are going to see only these 2 bits, namely TF0 and TR0 and TR0 or TF1 and TR1 only, because these IE1, IT1 are related to interrupts. So when we are dealing with interrupt routines, that we will discuss that during your interrupt routines. Okay, during the interrupt routines. So timer overflow, and this is your timer overflow bit and timer run bit. Okay, this is your timer overflow bit and timer run bit. That we will see how to use the timer overflow for your timer. Meaning when you want to start the timer or the counter related operation, you need to instruct the microcontroller by setting this TR bit as 1. If this is 1, your microcontroller 8051 will start the timer or counter related operation And similarly, when your timer or overflow, for the overflow flag, for example, if I need to count only 10 persons entering into the room, okay, 10 persons entering into the room, when the value reaches 10, when the counter value reaches 10, automatically the timer overflow, I have to stop the counting, I have to stop the counting. Automatically your timer overflow flag, a timer overflow flag will be made one, will be automatically, it is made one, indicating the 8051 microcontroller or instructing the 8051 microcontrollers to stop the counting, that is your timer overflow flag. So we will discuss each mode, so programming modes separately, namely mode, first let us go ahead with mode 1. Okay. mm, okay, mode 1, we can use it as an 8-bit programming also, or you can use it as a 16-bit programming also, you can use this as a 16-bit programming also. So let me go ahead with mode 1 first. Okay, let me go ahead with mode 1 first. Provided mode 0, mode 0 we will discuss later. First we will discuss with mode 1. So mode 1, so we will be using, as I said already, if it is a timer related operation, you will be using the internal crystal oscillator, you will be the internal crystal oscillator as the clock, okay, as the clock. So what you will do, you know what is the time related to one machine cycle. So crystal oscillator, and divided by 12 will give you your machine cycle, okay. And provided when your C bar, T bar, okay, C bar, T bar, which is there in your timer mode register. Timer mode register, it is again an 8-bit register, it is an 8-bit register. This is for timer 0, this is for timer 1. The first bit is your gate, the second bit is C bar, T bar register, and then this is your mode 1 and mode 0, okay, mode 0, and this is the replica for mode timer 0 also, okay. So this is C bar, T bar register. So C bar T, when your timer, okay, so when your this bit is 1, when your this bit is 1, meaning C bar T bar, in the sense when this is 1, it is counter related operation. When this is 0, because it's an active low signal, it's a T bar, active low signal, it is used as a timer related operation, okay. So now here in this case it is used for timer related operation. Let me make C bar T bar as 0, C bar T bar as 0, meaning this entire pin bit is 0. So now I'll be having an AND gate here internally. So this is your TR bit, timer run bit. This is there for 0, timer 0 register as well as timer 1 register, okay. So you have a clock signal here, and whose output is there. What you will be having, you have it's used as a 16-bit timer now, okay, it is used as a 16-bit timer now. So you have a THL and you have a TH timer register, you have two, okay, you have two, one is TH and TL, and this may be T0 or T1, okay, T0 register or T1 register, both are 16-bit register. You can individually access this, but now in mode 1 you are going to access this timer register as a 16-bit register, okay. 16-bit register, meaning you are going to load the count value, load a 16-bit count value in this register, and then you are going to start the timer related operation. Meaning, for example, if I want to complete a task within 5 minutes, that 5 minutes will be loaded here, in terms of hexadecimal, and using the timer run bit I am going to start load the count and then start the counting, okay. Once this is okay, once this is for example, count down operation. For example, for counting down operation, I am writing in 10 decimal. So when it reaches 0, it's a 16-bit register. So it will be 00. Let me load this count value 0008H. So if for each clock cycle, the count value will be decremented by the 1, or the timer value will be decremented by the 1, 007 for the next clock cycle, and 6, and it goes on and on. It goes 000, and then from 000, it will go to FFFH. When you subtract 0000 with -1, you will have FFFH. So whenever your this timer register reaches this FFF, your timer overflow register, which is nothing but TF register, will be set to 1, indicating the microcontroller that the timer related operation is over. This is the diagram or the steps that we will be following. So timer overflow flag. Okay, I repeat. So we can load any value in the 16-bit register. From 0000 to FFFH. Okay, FFFH. After this, after the timer registers are loaded with the count value. Okay, count value. You will be making this TR bit. Okay, you will be instructing the TR bit, or the TR flag is raised. To start the counting. How will you start the counting? I need to make this TR bit to be 1. How will you make this? By using set to be TR register. Either it may be TR0 or TR1, or TR0 or TR1. After that, for each clock cycle, your timer value will be decremented, and finally it rolls down from 0 to FFFH. When it reaches from 00 to FFFH, when it reaches from 00 to triple F triple FH, what it will do, your timer overflow flag automatically it will be raised to 1. Timer overflow flag will be raised to 1, indicating that the timer related operation or the counter related operation is over. It is over. Now how you are going to program it? First, programming in the sense, so how we are going to program this? First, okay, we know that we need to load a 16-bit timer value, or the count value in the timer, either in the timer register 0 or in the timer register 1. And we need to use especially your timer mode register, because you need to program the timer either in which mode you want. Okay, first we are dealing with mode 1. So we need to program the timer mode register with the mode 1 programming. So we know what is your timer mode register. So timer mode register, let me use timer 1 itself. Okay, let me use timer 1. Okay, so in timer 1 we will be having gate C bar, T bar, and M1, M0. Okay, and this is the replica of the same bits, gate C bar, T bar. This is for timer 0, and this is for timer 1. Okay, I am going to use timer 1 now. So we are going to program this by in mode 1. Okay, and moreover we are going to use software related control for controlling the operation of your timer register and the counter register, or the counter register. We are going to use software related instructions. So for that, your gate bit has to be 0. So what will be the value of T mod register is, okay, this is your T mod. Okay, this is your T mod register. So T mod register, what am I going to do? I'm not going to use anything here. I'm not going to use anything in the timer 0. So everything is 0. All the 4 bits are 0. Whereas here I'm going to use this gate as a software control related instruction, means gate should be 0. So this will be 0, and throughout our discussion of this entire timer, this gate will be 0 only. Okay, we are not going to use any external related source for controlling your timer related operation. We are going to use only software related instructions for controlling the timer related operation. And moreover, your timer, okay, timer 0 in mode 1. Okay, so now it is your timer related operation. We are going to use timer related operation only. So it will be active low signal. So this has to be 0, this bit has to be 0, so the next bit is also 0, and you need to program this in mode 1. And we know that in mode 1 means 0 and 1. Mode 1 is 0 and 1. Okay, in both the value I'll tell you how to use this. Okay, I'll tell you. So this is 0 and 1. Okay, timer 0 and 1. Okay, this is for your timer 1. So the equivalent thing is 0 0 0 1 is 1, and this is 0, so 1 0 H. Okay, so you need to give the timer mod register, you need to feed this data 10H by using move okay, move instruction, data transfer instruction, T mod register. This is also an 8-bit register, comma hash 10H. So what is the meaning? You're going to use timer 1 register in mode 1. Okay, in mode 1. Is it okay? So then after giving the instructing that which mode that we are going to select, we need to load the count value. Okay, we have instructed now, we are going to use, we have instructed the 8051 microcontroller that we are going to use timer 1 register, and we are going to use mode 1. Okay, so the next thing is what we need to do according to this diagram. We need to load the count value. We need to load the count value. Again, how to load this count value? Okay, so for load this count value, again you are going to use move instructions only. I'm going to use timer registers. So timer register 1, so move TH1 and TL1. Okay, TL1, I'm going to load this by the count value. Okay, count value, I'll write it as count value as such. Now I'm going to load this by the count value. Okay, after loading the count value, see, I have instructed I'm going to use timer 1, I'm going to use mode 1, and then I have loaded the count values. After doing this step, okay, after loading the count value, I need to start the timing related operation. For that I need to set the bit TR is timer run. Okay, meaning initiate the timer related operation. Timer run flag bit. This bit is available in TCON register, timer control register. For this, as I said already, this timer and the counter related operations are controlled by the software, that is why we have made this gate to be 0. So we need to instruct the microcontroller to start the timer related operation. For that you need to set this bit whenever your TR bit is equal to 1, meaning you need to start the timer or the counter related operation. So use instruction set B TR1 because we are using timer 1. Okay, we are using timer 1. And then, okay, so it is done. I need to say once this timing operation is over. For example, if I want to do one particular event for 5 minutes only, okay, the timer register, this 5 minutes will be loaded as a count value in the timer 1 register, and then I have started the timer related operation. So whenever this 5 minute reaches 0, okay, 5 minutes, 4 minutes, 3 minutes, 2 minutes, 1, and then if it reaches 0, and when it rolls down according to microcontroller, when it rolls down this 16-bit count value, it will be a step down value. So let it be 0005, 4 minutes, 3 minutes, 2 minutes, 1 minutes. From this 0 minute, when it reaches from 0 to FFFFH, okay, when it reaches from 0 to FFFFH, automatically your timer overflow flag will be set to 1. So we need to monitor this flag whether 5 minutes is over or not. So how will be using that, okay, jump on, okay, we need to use bit related instruction because this is a bit, so jump on no bit, okay, jump on no bit, check your which flag, TF1's flag, because we are using timer 1, jump on no bit TF1 comma, again do this operation again and again till my overflow flag is set to 1. I have not reached the time 0, till then you do this operation, check this flag again and again, after that automatically for the next operation, okay, for the next operation to continue, what I'll do, I'll be clearing this TR1, I will be clearing this TF1, because both the flag has to be set, cleared before performing the next timer or the counter related operation, okay, counter related operation. This is how we'll be programming, using the program, doing the program in mode 1, okay, for timer in mode 1. So for example, if I want to generate, okay, if I want to generate again a square waveform with 50% duty cycle, okay, duty cycle, how we are going to use it, okay. So let us go ahead with how we are going to do, okay. And we know that the same thing here also, one machine cycle, if it is if your crystal oscillator frequency is 11.0592 megahertz, one machine cycle will be 1.085 microseconds, and yeah. So then how we are going to load the delay? So you are going to load any 16-bit value, by using this calculation. For example, in the same way, if I am going to use, I am going to create a 3 kilohertz square waveform. I am going to use generate a 3 kilohertz square waveform, provided this is your on time 50%, means this is 1.5 kilohertz and 1.5 kilohertz. So 1 by 3 into 10 power 3, so it will be 1 by 3 milliseconds, let it be 2 kilohertz, it will be easy for me. So this will be 0.5 milliseconds. So 0.5 milliseconds means 0.5 millisecond is your total time, of which 0.25 millisecond is your on time, and 0.25 milliseconds it will be your off time, because 50% duty cycle, okay, 50% duty cycle. And we know now one machine cycle will be equal to 1.085, and now we need how much delay? We need so the delay will be number of counts into 1.085 microseconds will be equal to how much delay is your 0.25 milliseconds. From this calculate the count value. Okay, calculate the count value. After finding the count value, convert this into hexadecimal. It will be a 16-bit hexadecimal. As I said earlier, the counter will be a step down counter. So what you need to do is, I will be subtracting FFFH by minus this count value in hexadecimal. That will be loaded in the timer register. Then load this in the timer register. Okay, load this in the timer register. This timer 0 can be used as a 16-bit timer. Okay, as I said earlier. Now both we are using both. For example, in this example we have used a timer 1 register, meaning TH1 and TL1 both are used for loading up the 16-bit value. Okay, 16-bit value. Whereas if this is nothing but a 16-bit timer and counter register, timer or counter register. And in the same way, this can also be used as TL1, only 5 bits of TH1, meaning this is 0 to 7, 8 bits. The next is 5 bits is nothing but 8, 9, 10, 11, 12. So we are going to use from 0 to 12 bit only. This is nothing but said to be a pre-scalar value. Okay, this pre-scalar is added here now. It will be acted as a 16-bit timer, 12-bit timer or counter. Okay, timer or counter. And coming to your program, I'll just let us generate a square waveform with 50% time delay. That count value and all you will be having, you can count it and you can do it using Keil. So first I am moving this T mod. Okay, first I need to program move T mod comma hash 10, because timer in mode 1 as I said earlier, and then move and TH1 with the count value, and move TL1 by a count value. Okay, and then again what I have to do, first initially complement your bit. I am using port P0.1. okay, complement your bit and call your delay. Already you have called your delay. What is your delay? In the delay routine, okay, in the delay routine, what you need to do? First you need to start the timer related operation. Set V TR1. For that you need to set it, and then we need to monitor your TF flag, TF1 comma again. So again, when this is 0, after this is 0, automatically clear your TR1, clear your TF1, return to the main program. Okay, return to the main program. So here you need to return. So short jump here. So here will be again you need to load the count value and do the operation. Okay, this is how you will be generating a square waveform with 50% time delay, and coming to your timer 0, okay, or timer 1. So timer 0, it is again So timer 0 or mode 0. Mode 0 is a 13-bit timer mode. Okay, 13-bit timer mode. It's a 13-bit timer mode instead of 16-bit. Okay, instead of 16-bit. Mode 0, the same process. It's 13-bit timer instead of 16-bit. So 13-bit in the sense from 0000 till 0, 13-bit, no? So 1 F F F H. So 4, 8, 12, 13th bit alone I can use. Either it can be 0 or 1. The maximum range will be from 0 to 1. Okay, 4, 8, 12, 13. So this is the maximum count value that can be loaded. Okay, when it rolls down from, when the timer rolls down from 1 triple FH to 00 to 1 triple FH, your automatically your timer overflow flag will be set to 1. Okay, timer overflow flag will be set to 1. I hope you are getting me. With this I'll stop today. Okay.